Alright, good day everyone. So welcome back to my YouTube channel. We are now in integration by U substitution or by integration by substitution. So same U substitution or substitution. So this is integral calculus and welcome to Kasaligan Vlogs. So what is integration by substitution? So that is based on definition of Felician and Oy. Some integrals cannot be evaluated readily by direct application of the standard integration formulas. The technique for evaluating such integrals leans heavily on what is known as method of substitution. These methods involve a change of variables, say from x to another variable u. The purpose of substituting a new variable is to bring the problem to a form for which a standard formula can be applied. This integration by so-called chain rule for integration. So I will be teaching to you on how to solve integration by substitution. So let's evaluate the following. We have 8 questions to evaluate. Okay, so let's start with number 1. So in number 1, we have integral of 2x plus 5 cubed dx. That's what I've stated a while ago, that you could not apply I4 here immediately because u is not equal to x. How to apply I4? We could apply immediately I4 if u is equal to x. Since u is not equal to x, so let's use integration by substitution. So our u understood here, our u is equal to 2x plus 5. So if we're going to take the derivative of this one, we have 2 dx, right? So 2 dx. So since by integration of substitution, we have to substitute all parts of this one. The part here and the part here. Since we have now the value for this 2x plus 5, which is our u, we need to find the value for our dx. Since we have 2 here, we could not put immediately that the value for dx is du because we have the 2 here. So we need an adjustment at what we call as the neutralizing factor. Or adjust. Okay. So we have here the NF. So we need to adjust this part. So therefore, our NF here is 1/2. So okay. So 1/2 du is equal to dx. So our neutralizing factor is 1/2. So by the use of this part, so integral of u times u cubed times the value for our dx is 1/2 du. Alright. So if we're going to integrate outside, move the constant u cubed du. So we have 1/2 u 3 plus 1 over 3 plus 1, then plus c. So this is u raised to 4 over 3 plus 1, that is 4 times 2, that is 8 plus c. So now we have to substitute the value for our u. The value for our u is 2x plus 5 raised to 4 plus c over 8. So this is the answer if we're going to have this number 1. Okay, so that's it. So again, we cannot use immediately I4 if that u is not equal to x. So let's proceed with number 2. In number 2, we have the integral of x. We have x squared plus 1 squared dx. How to determine the value for u? So the first thing is we need to anticipate that if we're going to take the derivative of our u, there is a corresponding value to that one that would also cater the other variable. So let's say if this is our u is equal to x, du is equal to dx. what is the value for this one. So it could not cater sa x squared plus 1. How about if we will let u is equal to x squared plus 1? Can we cater x? Let's try. Du is equal to, we have 2x dx. So this time we could cater x and dx, but we need to have the neutralizing factor, which is 1/2. So x dx, if we're going to combine here, that is our 1/2 du. So this is become 1/2 du is equal to x dx. So we have now the value for x dx, the value for x squared plus 1. Again, how to choose u? You have to think at first the derivative. If we could make it possibly, we could support the other variable of k. Okay, so integral of this part. So this is u here is u squared plus x dx would have du 1/2. Okay, so since we have here 1/2 integral of u squared du, okay, so 1/2, we have u 2 plus 1 over 2 plus 1, then plus c. So we have u raised to cube over 2 plus 1, 3 times 2, that is equal to 6 plus c. So what is the value for u? We have x squared plus 1 cube over 6 plus c. Okay, so that's it. That's how to use method of substitution, integration by substitution. Let's have number 3. So in number 3, we have here the problem x squared plus 1 then squared dx. Can we use integration by substitution? Let's try. So u is equal to x squared plus 1. Our du is equal to 2x dx. So this time, we could not make use of this because we could not find here x dx in the problem. So unknown. So therefore, there is another way to solve this one. Okay, so we could not make use of substitution because there's no x attached here that will cater that there is an x dx in the problem. Okay, so we have here integral of x squared plus 1. So we could not use substitution. So x squared dx. So just simply we have x raised to 4 plus twice the product of this one, 2x squared plus square the last term. Okay, square the first term, twice the product, and x squared plus 1 plus 1. Okay, so integral of x raised to 4 dx plus 2 integral of x squared dx plus integral of dx. So this is x raised to 5 over 5, right? 5 over 5 plus 2 x raised to 3 over 3 plus the integration of this one is x plus c. Okay, so this is x raised to 5 over 5 plus 2 over x cubed over 3 plus x plus c. Okay, so this is the final answer for number 3. So let's proceed with number 4. So in number 4, okay, integral of the square root of 2 minus 3x dx. Okay. Are you here understood that this is 2 minus 3x? Let's try. Du is equal to negative 3 dx. Okay. since this is negative 3 dx, so since walang 3 dito, we need to have the NF, which is negative 1/3, the neutralizing factor. So this negative 1/3 du is equal to dx. So we have now dx as the value for this one, which is negative 1/3 du, and the value for this 2 minus x, which is ru. So now integral of u times negative 1/3 du. So integral of negative 1/3 u du. Okay, negative 1/3. So this is u 1 plus 1 over 1 plus 1, then plus c. Okay. Next, this is square root, rather square root. So this is 1/2, rather the square root. This is 1/2. Okay, this is square root. So we could express u is equal to square root of u, that is u raised to 1/2. So that's why you have u raised to 1/2 plus 1, 1/2 plus 1. So negative 1/3, that is u raised to 3/2. Alright, 1/2 plus s 3/2 over 3/2, then plus c. So take the reciprocal of this y. So the result of this part is negative. Take the reciprocal, we have 2 over 9 u raised to 3/2, then plus c. So 9, why is it? Because 3 times 3, then 2 is in the numerator. Okay. So negative 2 over 9, then times, what is the value for our u? Our u is 2 minus 3x raised to 3/2 plus c. Okay, so we can have this negative 2 minus 3x raised to 3/2 over 9 plus c. Okay, so again, this is 2 minus 3x raised to 3/2 plus c. Okay, that's number 4. Let's proceed with number 5. The problem for number 5 is integral of x squared, then this which is 2x cubed minus 1 raised to 4 dx. Again, how to determine the value of u? We have to anticipate first its derivative. If we make use of this one as our u, the derivative of this one is 2x, and we could not cater here, 2x cubed minus 1. If we will let this one as our u, 2x cubed, the derivative of this one is 6x squared, and we could cater x squared here, right? Okay, that's it. So therefore our u is this. So 2x cubed minus 1, our du is equal to 6x dx. Alright, 6x squared dx. So now 6x squared, we could have this part. Alright, so complete na lahat. We could now get the substitution here. So NF is equal to 1/6. So therefore 1/6 du is equal to x squared dx. So integral of our u raised to 4, then we have 1/6 du. So integral of 1/6 integral of u raised to 4 du is equal to 1/6 raised to 5 over 5, then plus c. So u raised to 5 over 30 plus c. So let's have u is 2x cubed minus 1 raised to 5 over 30 plus c. Okay, that's it for number 5. Let's proceed with number 6. In number 6, this is the integral of 2x plus 3 over x squared plus 3x plus 4 dx. So how to determine u? If this is our u, could we cater this one? No. If this is our u, could we cater this one? Yes, because this is 2x plus 3. Yes, we could cater 2x plus 3. Okay, so our u is equal to x squared plus 3x plus 4. And the derivative of this one, du, is equal to 2x plus 3 dx. Okay, so now this part, this is our du. So integral of, this is our du, and this is our u. So integral of du over u, that is ln of u plus c. So therefore we have the ln of, what is our u? We have x squared plus 3x plus 4 plus c. Okay, that's it for number 6. Let's proceed with number 7. The integral of x squared dx over x cubed minus 1 raised to 4. So what would be the possible u here? So if this is our u, could we cater here? No. If this is our u, could we cater here? Yes. So therefore this is our u, which is x cubed minus 1. Our du is equal to 3x squared dx. So since we have here x squared dx, so we could cater now. Okay, so nf, which is 1/3. So 1/3 du is equal to x squared dx. So integral of, this is 1/3 du over, which is our u, which is u raised to 4 rather, u raised to 4. So 1/3 integral of du over u raised to 4. So we could have integral of u raised to negative 4 du. 1/3. So this is u raised to negative 4 plus 1 over negative 4 plus 1, then plus c. So 1/3. So this is u raised to negative 3 over negative 3 plus c. So negative 3 times negative 3, that is equal to negative 9. So negative, and this is u raised to negative 3, so therefore 1 over 9u cubed plus c. Okay, so negative 1 over 9, and the value for our u is x cubed minus 1 cubed then plus c. So this is the answer for number 7. Okay, so let's have the last part, which is number 8. Number 8, we have integral of dx over x ln squared x. Okay, so what is our u? Of course, understood, this is ln squared x, because we cannot make use of this as u because we cannot help ln x squared. So our u is equal to ln x. Our du is equal to 1 over x dx. Okay, so since 1 over x dx, we could say that we cater dx over x or ln x. So integral of this is du over ru, which is u squared. So this is integral of u raised to negative 2 du. Okay, u raised to negative 2 plus 1 over negative 2 plus 1 plus c. So u raised to negative 1 over negative 1. Then plus c. So negative 1 over u plus c. So negative 1 over, what is our u? Which is ln x plus c. So this is the final answer. Negative 1 over ln x plus c. Okay, try this at home. Evaluate the following. So I hope you solve that one at home heartily. And please ask questions. Just raise your questions. Just message me in the messenger if you have questions. So evaluate. We have 1 to 3, and I hope everyone to enjoy solving this part. Good luck, and do not forget to subscribe and share the channel. Thank you, and God bless.